Hi, this is Anirudh, and in today's video we'll be doing sums from dielectrics inside capacitors as a part of electrostatics. Please do follow us on our Facebook, Instagram and Telegram channels for your daily dose of math and physics. Let's get started with our JEE problems. So the first question of the day states that the voltage rating of a parallel plate capacitor is 1000 volt. If its dielectric has a constant value 10 and its dielectric strength is 10 to the power 6 volt per meter, then the minimum separation required between the plates so that the field never exceeds 20% of the dielectric strength is. So firstly, we know what the voltage is. Its operating voltage is 1000 volts, and let's assume that the distance between the plates is d. So we can find the electric field in the region. Electric field is given by V by d. That is 1000 divided by the separation distance, that is d. Now this is the electric field that should have been there, but since there's a dielectric with a dielectric value of 10, so the experimentally found electric field value will drop by a factor of 10. So it would come to be 100 d. It says that the permitted electric field is 20% of the dielectric strength, that is 10 to the power 6. So the permitted E, let's name that EP, is 20 by 100 into 10 to the power 6 volt per meter. You can just cut out here, one cuts out here, you have 2 into 10 to the power 5. Now this permitted value should be equal to the experimental value, so we just equate EP and ED. EP should be equal to ED, or 100D should be equal to 2 into 10 to the power 5. Can cut out the 100, leaves it with the 10 to the power 3. Therefore D becomes 1 by 2 into 10 to the power minus 3, that is 1 by 2 is 0.5. 0.5 into 10 to the power minus 3, that is, this is in meters, remember, that means 0.5 millimeters. So our first option is our correct option. Let's move on to the next sum. The second question involves a combination of dielectrics, that means 3 different types of dielectrics are placed within the same capacitor. These kind of problems are very important for JEE. You can get in parallel combinations or series combinations. The way to approach this sum is to treat these 3 dielectric regions as different capacitors. Let's call this the first capacitor C1, the second region as the second capacitor C2, and this as C3. So our job first is to find the value of C1, C2 and C3. We know that the capacitance of C1 will be epsilon naught A by D. Now this is the general formula of capacitance. The area is the same plate area A, but the distance in this case for the C1 is D1, and you also have a dielectric K1. So this is your value of C1. Same way you get C2, that would be K2 epsilon naught A by D2, and you'll get C3, that is K3 epsilon naught A by D3. Now these 3 capacitors over here are in series connection because you think of them to be capacitor that follows one after the other. So we just apply the series combination of all 3. So the equivalent capacitance is 1 by C1 plus 1 by C2 plus 1 by C3. The values gives me D1 by K1 epsilon naught A, D2 by K2 epsilon naught A plus D3 by K3 epsilon naught A. I can take the epsilon naught A common from all 3, so I have 1 by epsilon naught A, D1 by K1 plus D2 by K2 plus D3 by K3. So remember, this is the reciprocal of the equivalent capacitance. So the actual equivalent capacitance would be C equivalent would be equal to by K2 plus D3 by K3. So our correct option is option number 1. Now in the next sum we'll be doing a similar kind of sum. Let's move on to the next sum. This sum is just a slightly more complicated version of our previous sum. In this case again you have three different dielectrics inside the same capacitance, but their arrangement is a little different. So once again we'll proceed in a similar way. We'll treat this as one capacitor, this as the second, and this as the third capacitor, and find capacitance for each of them. So the C1, let's call this capacitance as C1, this as C2, and this as C3. So C1 is equal to K1 epsilon naught, the area is A by 2, so A by 2 divided by the distance is D by 2. The by 2's cancel out from both, you just have K1 epsilon naught A by D1, sorry, D. When you're moving to C2, C2 is similar way, K2 epsilon naught, again it has the same area A by 2, and its distance between the plates is going to be D by 2. Again the by 2's cancel out and you have K2 epsilon naught A divided by D. The last one is our C3, the bigger dielectric over here. That will be equal to K3 epsilon naught A by 2, because its area is also A by 2, divided by the entire length D. So this becomes K3 epsilon naught A by 2D. Now in this arrangement these two are in series like we did in the previous sum, and the series equivalent of these two is together in parallel with the third one. So let's first find the equivalent of these two. So we'll call that the C equivalent of the series. So two capacitors, when they are in series we can directly put the formula. You have C1 C2 divided by C1 plus C2, and this equivalent is in series with the is in parallel with the third capacitor C3. So the final equivalent capacitance is just this plus C3, because remember in series combination they add reciprocally, in parallel combination they simply add up. So let's put the C1 C2 plus C3. Just segment this out. Putting the values from here, you have, I can take epsilon naught A by D common, A by D into K1 epsilon naught A by D into K2 divided by epsilon naught A by D. I can take common from these two and I just have K1 plus K2. One of these I can cancel out and you have the C3 part over here, that is K3 epsilon naught A by 2D. So I can take the epsilon naught A by D common from both of them and you will be left with the final equation, that is epsilon naught A by D K1 into K2 by K1 plus K2 plus you have a K3 and you also have the factor 2 here, so plus K3 divided by 2. So our correct option is option number 3. That's all we have for today. We'll see you again in the next. Like, comment and subscribe to our YouTube channel Mathophy for your daily dose of math and physics.